this is my multi-access memory. Now, just before we go, my slime blocks are purple. Don't know why, it's just a glitch. I can fix it, but I can't be bothered. But I consider this a really big achievement. I have this pretty compact. I do want it to be multi-write. Now, at the moment, you can only write to one section of data at a time. Down here is basically where you select what you want to read. So I'll actually change these. So we're reading all different ones. And if I come up here, as we can see, I'm reading different lines of data all at the same time, and I can also access the same data on all of them, and it's relatively quick. Deselecting actually takes longer, and that's your read time, and now to unread actually takes longer, as you can see, but it's not too bad. Now that isn't accessing the very front, it does take a little longer to access the very back, but it's not too bad. This stores 15 bytes of information all in 1 byte sections, so it's not the biggest when it comes to capacity. It's quite small, but I call this reasonably compact if you compare it to my original design. This thing right here is my original design. This is what I built when I first came up with the concept of trying to do it, and this is fully functional. It is a little slow, but it does work, as I'll demonstrate. As you can see, it's a little slow and everything loads in. This was mainly a proof of concept that I could actually do this, and then I worked on compacting it. One thing you'll notice is how each individual color has its own Y level. This was one of my complete prototypes after I did some work on it. What's different is actually the colors now go down, so they're all rowed like that. This one actually makes it a little easier to explain, so I'm going to explain a bit on this one, and then I'll show you how my most compact one works. Right here is 4 bits that is going into the system, and down here is a line that we're actually selecting to read. At the moment we're selecting to read this line, as you can see, and that line, and I can unselect that other one down there, and as you can see, it unreads it, and I can do the same for this one. Now the main problem with this is I wanted to keep it within one block. Now it didn't have to be right next to each other, but it still has to remain small. And the hard part is actually sending a signal upwards while trying to send a signal through it, right? I worked out with slime blocks and pistons, you can actually send a signal through it and still have the piston move up, which solves that issue. Now the main core of this is basically, so the way this actually functions is I use 2 NOT gates. As you can see, the signal passes across down the whole line, but it also goes down into this double NOT gate. So it means at the end of the signal, it's still the same signal, but what this allows me to do with the middle NOT or the second NOT gate is I can actually power that block, locking the output. So if I come down here and actually power this, as you can see, I'm powering this block, which actually turns this torch off. No matter what this is outputting, this will always be off as long as this is on, therefore getting rid of the signal. This also means it will not affect different sections when I'm reading data from them. And that is the core of the design. Now, I did some work in compacting it. I'm going to measure out the difference in distance. It's 7 by 11 blocks. Let's compare that. This is my most compact design. As you can tell, it is a fair bit smaller, and I still have all the same outputs, but it still functions in the exact same way. And to show you how much smaller it is 8 by 6. So I went one taller, but I reduced the length of it by a lot. Now this is pretty much just a complete slice, minus the decoder there, right out of that. So you can actually see how all this interacts. So I can actually set these all to be on, and I can set that, and this actually shows you how the memory circuit works. Now that is not an original design by me, that's by this person. I'll find the video again. I think it was a very, very smart design, and I've used that as my core of it, and I've built around it. I didn't really look at much else he did. The only other thing that is definitely from his video, which is actually not on this design but on the non-multi-access, is actually this. is actually this little piston feed here that allows me to push it up and get a signal onto one line and then push it down so I don't get a signal. Now, I'd love your feedback on this design. I'd also love to see you try to make it more compact. 15 bytes with 4 outputs, or singly able to be addressed. I'm really curious if you can make it smaller or not. I'm sure it's probably possible. I think the main thing you could probably make smaller is this actual central memory design, and this output area here could be smaller, more than likely. Another thing I wanted to add, a lot of things I do, I actually try my best not to Google it, because I love the challenge of Redstone, and to me Googling it it's like looking up the answer to a puzzle. And I will do it if I get stuck, and I do that when I think I've actually mastered a design, to just see if I can get it better and what I've actually missed. But it does mean I come up with things and then people show a very obvious thing that is a lot more compact and probably well known. I just want to bring that up because that's probably in this build. I don't really Google for Redstone. I try to make it up as much as I can. Now this build does have components from other people, but again, that was a necessary step for me to move forward, because I hit a boundary where I couldn't think of another way to do it, and me looking it up allowed me to work out a core component, make it smaller, and then from there build out.